and you can go and get into your game and do whatever you want. There's some useful information down here like the drop frames and your current speeds as well. Once you've finished, click on stop streaming. It will say you'll not be able to reconnect. That's fine, I'll press yes. And now you've stopped your stream. So that's it, guys. If you found this useful, then leave a like.
Welcome to episode -1 of our Introduction to Programming series. In this episode, we'll be talking about what topics and information will be covered throughout the duration of this tutorial series. The Introduction to Programming course consists of 15 videos covering the basics of computer programming, which can apply to any and all programming languages. We'll be starting with the simple question of what is programming, and then ramp up from there as we talk about common features of computer science. We'll talk about how to read and write code, and also how we can get our computer to understand the code we're writing. Next,
So in this video, I'm going to walk you step by step on setting up your YouTube chat overlay inside of OBS Studio. So the first thing you're going to want to do is have your OBS Studio open, and then typically you're going to go ahead and add your chat overlay to your intermission screen. Now I have here my video, my gameplay, and then I have an empty box here for my chat overlay. Now what you're going to do is you're going to come to streamelements.com, and I'll put a link in the description of this video. Then you're going to get logged in with your YouTube account, and once you do, you'll be brought to a dashboard just like this. On the left-hand side, under streaming tools, just select overlays. This is going to bring you to a new dashboard, and then we'll select new overlay. We'll have it at 1080p, hit start, and now what we want to do here is we want to hit this little plus icon. We want to come towards the static and custom, and you'll select video if you have animated overlays, or an image if you have static overlays. And what I'm going to do to make this easier is I'm going to go ahead and bring in my just chatting scene to Stream Elements, so that way I can align it directly with the actual chat. Now, the overlays that I'm utilizing are going to be from streamdesigns.com, and they have tons of
And if I click right here at that little down arrow, it'll show live chat replay, and then you'll see all of them. When you're on the top chat replay or the top chat live, the YouTube kind of picks and chooses what you see. You won't always see like
Next, we'll dive headfirst into variables and how we can create and store values within them, manipulate them using basic math operations, and even compare them to determine similarity or differences. We'll work our way through loops, arrays, and errors, talk about how to import functions before moving on to creating our own functions, and hopefully, by the end of the series, you'll have a basic understanding of what computer science is, along with an armory of useful skills that will help you unravel whichever programming language you decide to learn first. We'll only be covering the major key points that apply to all programming languages, so if you experienced programmers are wondering why I didn't mention object-oriented programming or any specific languages, fear not, because we will have separate series that discuss these topics in depth. This is just a surface-level tutorial series. Additionally, there will be no software required for you to download in order to follow along with this tutorial, as we won't be writing any code to keep things simple and concentrated. This series is meant for those who are interested in computer science and programming, but have no idea where to start. And so if that sounds like you, then consider subscribing as we work our way through the basics of computer science, starting with the biggest question probably on your mind, which is what even is programming?
In this episode, we will be covering the big question: what is programming? The dictionary defines it as a process of preparing an instructional program for a device, but what exactly does that mean? Essentially, it is attempting to get a computer to complete a specific task without making mistakes. Imagine this, for example. You want your less than intelligent friend to complete a Lego set. If your friend is not given very specific instructions on how to build the set, there are many mistakes he can make. If he thinks like a computer, then if there is even one piece that you have not told him specifically where to place and how to place it, he may just place it wherever he wants, or even suffer a complete mental breakdown, causing the whole goal of the project to be corrupted. However, it is not as simple as just giving your friend the instruction manual. You see, computers don't understand the same language that you do. Computers only understand machine code, which is a numerical language known as binary that is designed so that the computer can quickly read it and carry out its instructions. Essentially, the computer is fed a string of ones and zeros and interprets this as instructions to carry out a task. Going back to your less than intellectual friend, now not only is he stupid, but to make matters worse, he cannot understand English. In order to speak with him, you have to convert the instructions that you understand in English into the language that your friend understands. And this is essentially what you must do for your computer to understand the instructions that you want it to carry out. The thing about machine code, however, is that it is very difficult for people to understand. Directly translating what you want the computer to do into machine code is extremely difficult, and would take a very long time to do if you knew how to do it. So how exactly do we translate our instructions into machine code? This is where programming languages come into play. Programming languages are fundamentally a middleman for translating a program into machine code. Programming languages are much easier for humans to learn and understand than machine
here to report that I officially started a stream for learning how to program. No one has joined. And it's like, yeah, I'm confronted with this harsh reality, which is like, if I want to learn how to program, I have to do it by myself. That's sort of the underlying message I'm getting. Like, when it comes to being in the trench, it's like at the climax of the battle, the climax of the firefight, I am completely alone. And that's a scary experience. I think that induces a lot of trauma because it's like my sense of reality sort of shifts. I don't even know what's going on anymore. I'm thinking about God. I'm thinking about what is real, what is not real. And I kind of lose sense of reality in a sense. And I get completely immersed in my imagination in a sense. And the learning experience is bridging my imagination with the reality of the situation. I'm trying to actually achieve a tangible result, and it's a creative expression. That's what makes the programming so intense, is that it's still a creative medium. It's not really real in the sense that a house is real, or in the sense that cutting grass is real, or in the sense, but there is something real about it. It's mathematically based. It's built on the giants of software. It's built on centuries of technology, of human technology. And so in a way, programming is kind of like a god. And maybe the mistake that I'm doing is that I'm treating it as if it's my god, and it's not my god. It's not my god. The technology is not my god. So why do I treat it like it is my god? And so, that's something that is interesting. This burning desire to build something, this passion to build something. I want to build, I want to create, I want to do something with my life, do something with my time, do something with my energy, do something that would be the pathfinding work for another human being to fathom and to understand. Um, and at the same time, it's like this pathfinding process burns. It burns my soul. It burns my very existence. It makes me question realities in ways that make me extremely uncomfortable, to the point where it's paralyzing. And I think there's some kind of ego death that is experienced with programming. And so it's really painful. It's almost like having a psychedelic experience, but doing it by myself. And it's like uncomfortable because the frontiers of my imagination are stimulated and activated, and it's like I'm waking the dragons of my id. And because of this, it's an extremely uncomfortable experience. And it's like, why am I doing this alone when I should be experiencing and confronting this either dream or nightmare, one of the two, with somebody else? I should not be doing this alone. The thing I'm really grateful for the Yahya ceremonies is that you do it with as a tribe, you do it as a group, and you're able to get some support, a little bit of emotional support, emotional, human, human support in this endeavor of exploring the mysteries of conscious existence and so forth. And I think programming is this environment of exploring consciousness in a real sense. It's a mirroring effect. And it's like the abyss, the id, the matrix, all of it is too much for me. And so no wonder I find myself paralyzed and afraid to work, because I'm looking for a little flame of human connection, of something real. And to me, human connection is real. It reminds me that I'm an animal. It reminds me that my consciousness may be a figment of my imagination. It reminds me that I'm here on this planet Earth, here in this universe that has X amount of dimensions and so forth. And it makes me just a little bit more grounded. And so it's sort of ironic that my endeavor in science has been one of inducing disconnection in myself or a disconnection with my reality, when in fact it's meant to have me better understand my reality. It's meant to have me better understand it. And in fact, I think it's induced disconnection. And so, having that said, I still have the desire to achieve the results. It's not like I don't want to achieve the results. So, I feel like I am encouraged to push forward and to just try and to find a method, a style, a means of processing this information so that when I'm doing it alone, I'm doing it comfortably alone. I'm traveling through deep space comfortably alone. And maybe that's what it is. It's an art of learning how to travel through deep space because I seem to be obsessed with traveling through deep space. I mean, my experience was one of literally traveling on a spaceship again. But I think my goal is to travel in low Earth orbit. I don't want to go venture off deep into space. I want to stick to low Earth orbit. I want to experience what it feels like to have air hit my vehicle. I want to experience what it feels like to deal with gravity and deal with resistance, air resistance. I want to be immersed. I want to be close to the planet as much as possible. I want it to be an experience where I can better experience the planet Earth for what it is and not necessarily get lost in space. And I think something about flight, something about space travel, there's so much more that we humans could be doing in this medium. We have satellites, but I think human beings could be living those altitudes a little bit more frequently. We have aircraft, but aircraft are only flying for a few hours. I think the closest that we have is what the U.S. Air Force does with their like radar network of or refueling vehicles, where people are pretty much living in the sky. Air Force One has a refueling system where it can stay in the sky indefinitely. And so I think that's sort of from a programming standpoint, from a social standpoint, I think that's sort of more or less where I want to be technologically speaking. I don't think I want to go into deep space. In fact, the more I think about it, the more I realize I don't want to travel into deep space. I may have a larger curiosity into the what's going on here on Earth because the forces are the same, the laws of physics are the same. The difference is that we have more molecules, so we have air resistance, and of course we have more intelligent life that's ongoing here on the planet, whether it's insects, mycelium, trees. Those are the three examples. And so more and more do I find myself gravitating towards something like the Amazon and what it offers, the energy, the very essence of what it offers. And I think from a programming standpoint, this is also what I'm curious about. And so I've reached out to programmers, I've reached out to several people to travel into this journey with. And so far I haven't gotten anyone to want to do the journey with me. And it's like I'm looking for someone to do the journey with me because I think it's safer. I think logically it just makes more sense to be able to travel with somebody um, instead of just doing it completely by myself. So that's what I think. That's sort of my general takeaway. And there's an intensity here. It's like I'm not walking away from intensity. I'm steadily going towards intensity, but it's a different kind. Which is really why I'm curious to see what Mexico has to offer because it might be the sort of counterbalance that I'm looking for to help me better gauge what it is I'm looking for. I think there's something special about being in deserts because deserts are so lifeless. Yeah, they have life, but there's a more lifeless approach to the desert, and I think I want to experience more of the desert more. in a way. I was in a desert, and I found that the desert was really cold. And there was really aggressive insects. I don't want to go anywhere where there's aggressive insects. And the desert had aggressive insects, so I decided, you know what, I don't want to stay here. I don't want to get bit by bugs all day. It's not fun. So I decided, you know what, the desert's not for me. And I'm wondering if it was for all deserts or just that particular desert. It seemed like it was for only that particular desert. But programming, man. Programming is a crazy space. Um, and I want to share this space with people, so I'm streaming live and I have no views. And I'm just like, oh man, even in streaming, it's like I haven't found support that I'm looking for. So I think I should just keep trying. I'm looking for just some kind of emotional support from somewhere. I'm looking to see if my girlfriends want emotional support, and it's like I can't rely on them for everything. I can't rely on them for everything. As much as I want to rely, as much as I want to rely on them, it's like I can't rely on them for everything. So it's like, who do I rely on? Where do I go for guidance? And I'm looking, and I'm begging God, please help me find the guidance that I seek. It's almost like I want another human to be my God, so I can worship them and learn from them. But that's not what I should do. I don't know what that sound was, but I'm still streaming. Yeah, I'm still streaming. Ah, I'm still looking, and I'm still looking, and I'm searching, and I'm searching. So let's try to
Code, and that's
navigate. Let's try to swim down this river, so to speak. And let's try to swim down this river of knowledge and learn how to do it alone. So I'll pause and I'm going to focus on the stream now.
very useful for programmers. Going back to our Lego example, a programming language would sort of be like an interpreter that's able to take the instructions you give them and translate it into instructions that your non-English speaking friend can understand. This makes programming languages extremely useful and the backbone of any good program. There are many different programming languages that each have their own unique uses. Languages such as Python and Java act as general-purpose languages that can perform a variety of computational tasks, while languages such as Robot-C or HTML and CSS are more so designed for specific purposes, such as moving a robot or constructing a website.
Had a Rubik's Cube
Languages can also vary in how powerful they are. For instance, JavaScript is a scripting language that is designed for smaller tasks, while Java or Python can carry out much more computationally taxing processes. Each programming language is measured by its similarity to machine code, the series of zeros and ones we talked about earlier. Low-level programming languages, such as assembly, are closer to binary than a high-level programming language, such as Java or Python. Aside from the different purpose that each language fulfills, choosing a programming language typically comes down to a matter of preference. Try different languages, and decide which one's rules, syntax, and level of simplification you like best. Next episode, we'll be going into more detail on how code is written and what tools us programmers use. If you enjoyed the video, subscribe to the channel, and maybe check out the rest of the videos in the series in the playlist linked to the right. Thank you for watching.
In today's episode, we will be covering IDEs and syntax. So how do we write code? It's not like we can simply type words into a text document and automatically assume that the computer can read it. As we talked about in the previous episode, the code must first be converted into machine code, a series of zeros and ones which the computer can then interpret and carry out to complete a certain task, like opening up a browser or a game. And additionally, we can't just write rubbish in the certain programming languages mentioned in the previous episode and expect the computer to understand it. So how do we do this? This is where an IDE comes in hand. An IDE stands for Integrated Development Environment and allows the facilitation of code by a computer. IDEs provide a graphic interface on which your computer can easily write, run, and debug code without having to worry about problems with compilation or interpretation of the program. Think of an IDE as any other program on your computer, such as a game or a browser or even the File Explorer, except we'll be using it to write code. Additionally, IDEs provide some useful tools for programmers to ease the job of writing code, such as built-in error checking, hotkeys for frequently used functions, and class hierarchy, which comes into play when talking about a specific type of programming known as object-oriented programming, which we'll talk about later. IDEs are sort of a way to fast-track writing code and make things a whole lot easier on programmers, which is why they're so popular. An example of a specific IDE, known as NetBeans, can be seen on your screen now. In the center, you can see the program that is currently being written, and right below it, the console, which can print out useful information for the programmer. The specific IDE.
I find that I'm sort of restless in the learning process, and it's like a thousand thoughts are racing through my mind when I'm trying to learn, and it's like there's like basic things that I'm already learning, and it's like I'm forcing myself to be linear, and it's like I'm not a linear thinker at all. Um, so it's like too structured. I think the problem I have with coding or taking watching tutorials is that they're too structured, but then learning how to teach myself is a bit too unstructured, it seems like. Um, and so that's what I'm noticing so far. But it's like torture. I find myself very uncomfortable just trying to get through the videos. Um, so, anyways,
is used to write Java code. IDEs are extremely powerful and will be used for the majority of tutorials on this channel. So through these IDEs, we are finally able to write and compile code smoothly without worry of the computer being able to understand it. The next problem we then run into becomes how do we write this code in the IDE? It's not like we can simply type in random words from a specific programming language and expect the compiler to understand it fully and completely. Now, just as if you were learning a real language, learning a computer language can be very similar. Some have different layouts that may seem odd, some may take on abstract or weird processes which may be confusing, and like all languages, programming languages have a set of rules that you must follow when writing code in that language, and at the forefront of these rules is the programming grammar. Programming grammar is referred to as syntax, and is very similar to real-world grammar. Each programming language has its own syntax, or rules, that you have to follow to a T if you want your program to run correctly, just as if you were speaking in real life. These can be things such as how you define certain variables, what you put at the end of the line of code, and how you use certain functions. Each language is unique in its own way, and while some may share similar rules or syntax, all will have a quirk which makes it stand out from the rest. Syntax is something that catches a lot of people off guard, since many expect each programming language to follow the same set of rules. But as we spoke about in the previous episode, because each language is specialized for a specific task, each needs its own set of rules to function. As an example, let's say we wanted to do something simple, such as initialize a variable, which is something we haven't covered yet, but the example is still relevant. In Java, you'll notice that we have to specify what type of variable we are defining, in this case an integer, and also add a semicolon after the statement is completed. In Python, we don't even need to define that we are trying to make a variable. We just need to type in the name of what we want to create.
and basically, like I can't really focus, so I'm like, I need a break. I need more human connection. I need something to recharge. But at the same time, I'm starting to realize you can't just trust. You can't just trust
When
anybody.
you get emotionally engaged with something, either you start to believe it more or you believe it less. There's no in between. So, like, when people see these kinds of memes, it literally shapes your thinking. And there's just a ton of science behind this, that the more emotional we get, it doesn't matter what kind of emotion, right? So if you sort of think about, like, whether you believe someone, I want y'all to say, like imagine for a moment that I'm like, hi, my name is blah, 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 and I swear I didn't do anything and I'm innocent. And then if you listen to that person, right, like, you're like, oh yeah, I don't know if I believe that person. A really great example of this is like Johnny Depp in his Amber Heard trial. If you guys watch clips of Johnny Depp, and he's like hilarious on the stand. And if you think about the psychological impact that has on your brain, if someone is funny and entertaining, you are more likely to believe them. That's like a fact, yo. Like a fact. So I think we do not realize that when we watch things like this actually shapes our thinking, whether you realize it or not. And this is what's really insane. So I'm going to ask y'all a question that's really hard to answer, which is, when you believe something about Collargate, what is that based on? Right? And we think it's based on evidence, but there's a really, really good chance that it's based on emotion. And I'm not saying that there isn't evidence that is supportive or not supportive. We'll kind of get to that in a second, okay? But like, I want y'all to really, really understand this, that the thoughts that your mind produces are not like super logical necessarily. Like, you have to work really hard to have like a logical thought. And this is what we see on the internet. We know there are tons of studies on online radicalization, which is the more time, it doesn't matter. The more time you spend in a particular bubble, the more your thoughts will be shaped in that bubble. I've had patients, it's fucking terrifying. I had one friend of mine, not a patient, whose wife started going down this like Instagram girl power, feminist, like toxic femininity, like misandry, like rabbit hole, and then like their marriage completely fell apart. I've also
Right. So to keep carrying on.
So, but once you find out, and you will be able to look beyond it, it's not going to be clarifying. It's only going to get more confusing for one, right?
Yeah. See, but this paper is will systematically deconstruct Allegro's claims, okay? Bidding him with the innovative linguistic mythology that underpins his entire project. From there, it will examine the neurolinguistic philosophy he attributes to ancient fertility cult, which
understand. Like actually if you're sharing your interview जिसमें if you're saying this कि तुमने एक interview दिया है Apple का and you were able to answer 70% of that fundamental questions, और like तुम्हें execute करने को नहीं बोला और DSA के कुछ questions दिए, right? That was the thing. 70% of a DSA, right? तो अगेन अभी मुझे समझ नहीं आया, पूरा एसेंस नहीं मिला मुझे ठीक से, तो इफ़ यू कैन गो विद द डिटेल तो दैट विल बी मच बेटर. बाकी अनिकेती सिंह, अरे भैया उन्होंने घर पे कॉल कर दिया, अरे भैया उन्होंने घर पे और घूम लो भाई बाहर. बाकी भैया ओके भैया, प्रॉब्लम 387 ब्रूट फोर्स तो हो गया था लेकिन ऑप्टिमाइज नहीं हुआ, वो क्वेश्चन आप कर सकते हैं क्या? अनिकेत वी कैन डू दैट क्वेश्चन. प्लान तो वही था क्वेश्चन करने का, बट देन आई गॉट दिस क्वेश्चन, क्या कहते हैं ये वाला क्वेश्चन जो कि मुझे डेविल 52 ने दिया था, एंड आई फेल्ट लाइक दिस क्वेश्चन इज गुड, तो इसके साथ जाने का मन कर रहा है. तो let's do this question, right? What I'm feeling. तो बाकी okay, I have to take this. ठीक है. तो Raj Singh is saying, bro, I have a better knowledge of everything, but to explain everything in English is difficult for me, and how to improve it. Yeah, if we're talking about communication or like English and all kind of a thing, तो भाई it can be done only through by doing it, right? तो तुम्हें डेली बेसिस पे करना पड़ेगा. तो इफ़ यू हैव अ बेटर अंडरस्टैंडिंग अबाउट एवरीथिंग, देखो ऑलरेडी तुमने जिस हिसाब से मुझे चीज़ें बताई, मतलब तुम्हारा डी से बढ़िया चल रहा है, फुल स्टैक बढ़िया चल रहा है, और आगे की एडवांस नॉलेज के लिए आगे बढ़ चुके हो, राइट? तो नाउ आई टेल यू वन.
And in JavaScript, we just specify that we are making a variable, but not include what type of variable we want to make. Even in this specific example, you can see how much syntax matters when learning a new language, since while the goal of our program remained the same, define an integer with a value of 3, all the programming languages shown took different approaches to this task. All these languages require that you follow this syntax because remember, computers are extremely dumb. If you forgot one semicolon or misplaced a single character, the entire program will not run and send you back a syntax error, which is something we'll talk about in a later episode. Think of this as if you forgot a comma in a sentence, and the entire context of what you were trying to say gets misinterpreted, like in the common example, "Let's eat, Grandma." If you forgot that comma in the middle of the sentence, while it may seem like such a small mistake, it changes the entire context of this, making it sound like you're about to eat your grandma, which is not good. The same rules follow for programming. If you forget a semicolon, the entire context of your program could be corrupted. Now, this is another thing which makes IDEs so useful, is that they will let you know if and when there are syntax errors in your code. Syntax errors are part of your code which don't follow the rules we talked about previously. The IDE will tell you where in your code the error is, and would even not let you run your program until the error has been fixed. Because of how important syntax is to writing code and learning a new language, it's recommended that you learn the rules and know-hows of a programming language before